I want you to do something for me right now. No, really.
No.
I know you're probably listening to this while you're doing something else, maybe driving at the gym, whatever. But I need you to just pause for a second.
Just for a moment.
Right. Wherever you are, I want you to stop. Take a breath. Now close your eyes. Seriously, close them.
Unless you're driving. If you're driving, please keep them open.
Yeah.
But you can still visualize with us.
Okay, good point. So you're in a space, a room, a car. You have a mental model of where you are. You know there's a wall to your left, maybe a window to your right. You feel the chair you're sitting on. You can sense the space.
Now keep that image locked in your mind. And I want you to ask yourself a very specific and kind of strange question. What does the room look like behind your head right now?
Don't turn around. Just answer. What is back there?
Your gut instinct, your brain's immediate response is to say, well, the room is back there, the bookshelf, the door. You picture it as this static, high-definition reality that's just, well, it's just waiting for you to turn your head.
But if we're going to listen to cognitive scientist Donald Hoffman and a pretty rapidly growing list of quantum physicists, you are wrong. It's not a bookshelf. It's not a door. It isn't even black.
It is literally nothing.
Nothing.
It hasn't been rendered yet.
Because there's no data stream?
No.
No consciousness directed at it. It's a void of uncomputed probability.
And the very moment you decide to turn your head, the millisecond your eyes start to sweep across that space, the universe or the system, it hurriedly renders the bookshelf. It just pops the pixels into existence right in time for you to see them.
Welcome to the deep dive.
Yeah.
Today we are taking the ultimate red pill. And I don't mean that in some, cheap political internet forum way. I mean it in the original Matrix, tear down the fabric of your reality sense.
We are not talking about science fiction today. This isn't just a cool movie plot or a what-if scenario for a stoned philosophy major in a dorm room.
No. We are talking about the mathematical, the biological, and the physical probability that the life you are living right now, this conversation, your hands, your memories, the very air you're breathing, is code.
Our mission today is, I think, maybe the most uncomfortable one we've ever taken on. We are going to try to dismantle your confidence in what you call base reality. We want to move you from thinking, oh, simulation theory, that's a fun thought experiment, to realizing that, statistically speaking, you are almost certainly living in a simulation right now.
Okay, that's a massive claim. Almost certainly. You're telling me the odds are better that I'm a line of code than a biological human being.
That is exactly what I'm saying, and I think by the end of this, you might just agree with me.
All right, let's unpack this, because usually when people hear simulation, they roll their eyes, right?
Yeah,
it feels like a cop-out. It feels like solipsism. Oh, nothing is real, so nothing matters.
Yeah.
But the argument, the real argument, it doesn't start with feelings. It starts with cold, hard, terrifying logic.
It does. It starts with the Trilemma. This comes from a paper published way back in 2003 by Nick Bostrom. He's a philosopher at Oxford University. And the paper is simply titled, Are We Living in a Simulation? And it honestly just changed the entire landscape of modern philosophy.
It's famous for a reason. So Bostrom proposes that one of three things must be true. Not might be true or could be true. Logic dictates that one of these three options is our reality.
Exactly. It's a logical trap. You're forced to pick one of the doors.
Okay, let's walk through the three doors. Door number one, what's behind it?
Door number one, the fraction of human-like civilizations that reach a post-human stage is essentially zero.
Post-human. What does that mean in this context?
It just means a civilization that has advanced its technology enough to run what he calls ancestor simulations. So basically, they have computers powerful enough to simulate their own history with conscious, sentient beings inside of it.
And door number one says nobody ever gets there. Ever.
Right. It says that every single civilization in the history of the universe, they go extinct before they reach that technological level.
So this is the great filter theory.
Exactly. And honestly, this is the door that keeps me up at night. The logic is that there is some hurdle, some challenge in the evolutionary or technological timeline that is almost impossible to get over. Maybe it's nuclear war. Maybe it's climate collapse.
Or maybe it's the technology itself. Maybe it's AI.
That's the leading candidate right now, isn't it?
Oh.
The idea is that as soon as a civilization gets powerful enough to build a perfect simulation, it is also powerful enough to destroy itself. I mean, think about us. We've had nuclear weapons for less than a century. We've had the internet for, 30, 40 years? We're about to give birth to AGI. On a cosmic scale, that's not even a millisecond.
It's nothing.
It's nothing. The great filter theory suggests that we are basically toddlers playing with loaded handguns, and statistically, the toddlers almost always shoot themselves before they grow up.
So if door number 1 is true, the reason we don't see simulations everywhere is because the universe is a graveyard.
Correct. Just silence. Everyone died.
Wow. Okay. That's cheery. Let's hope it's not that one. What is door number 2?
Door number 2 states that the fraction of post-human civilizations that are interested in running ancestor simulations is effectively 0.
So they survive. They don't blow themselves up. They build the planet-sized supercomputers, but they just don't bother.
Right. They have the tech, but they have absolutely no desire to use it for this purpose.
Why wouldn't they? I mean, look at us. We play video games constantly. We run simulations for weather, for economics, for war games. Why would a super advanced society suddenly lose interest in simulating things?
Well, there are a couple of strong arguments here. One is ethical. Maybe they reach a point of moral maturity where they realize that creating a conscious being, a being that can feel pain and heartbreak and terror inside a computer it's a monstrous act, a cosmic crime. If you run a simulation of Earth's history, you are creating World War II. You are creating the Black Plague. You are creating cancer in children. Maybe a truly post-human society looks at that and says, we cannot be the authors of that much suffering.
That's sort of the benevolent God argument. They're too good, too enlightened to run the sim.
Or there's the flip side, the boredom argument. Maybe they are so advanced, so far beyond us, that simulating our little slice of history would be like us simulating the behavior of bacteria in a petri dish. It's just boring.
We're not interesting enough.
They've moved on to dimensions of experience we can't even comprehend. They don't care about what happened in the 21st century any more than you care about what a specific anthill did last Tuesday. It's beneath them.
Okay, so door 1, everyone dies. Door 2, everyone gets super ethical or just super bored. But then there's door number 3.
Door number 3, we are almost certainly living in a computer simulation.
Okay, walk me through the jump there.
Yeah.
How do you get from it's a possibility to we are almost certainly in one? Because that feels like a huge leap.
It's purely a numbers game. It's just cold, hard statistics. So imagine a civilization reaches that post-human level of maturity. They don't die, and they don't lose interest. They decide, for whatever reason, historical research, entertainment, science, to run ancestor simulations.
Okay, if they boot one up.
They wouldn't run just one. That's the key. If you have a computer the size of a planet, which, physicists like Freeman Dyson have theorized is possible, you wouldn't run one instance of history. You would run millions, maybe billions.
Right, like we do with games.
Exactly, just like we run thousands of separate servers or instances of World of Warcraft, or millions of Excel spreadsheets doing different calculations, you would run variations. What if the asteroid missed the dinosaurs? What if Nikola Tesla got the funding instead of Edison? You'd want the data.
And you run billions of these simulations.
Okay, so now do the math with me. Suppose there is one base reality, the original biological mud and blood world where the creators live. And just for argument's sake, suppose they are running 1 billion simulations.
Got it. One real world, a billion sims.
Inside each of those 1 billion simulations, there are billions of conscious minds. Billions of people who think they are real, who feel love, who feel pain, who are listening to this right now.
So you have one original, real world and a billion simulated worlds.
Which means for every one biological person, there are billions, maybe trillions, of simulated people.
And since I don't have a little label on my forehead that says made in base reality.
Exactly. What are the odds that you, the person listening to this, are the one single, solitary biological entity in the original history? The odds are billions to 1 against it. You're statistically insignificant.
Wow.
If simulations are possible, and if even one civilization anywhere ever decides to run them, then you are a sim, period. The math is brutal.
That is the logical trap. You just can't escape the math unless you believe that literally everyone dies, or that literally everyone stops playing video games.
And looking at humanity, we absolutely love games. And we are trying very, very hard not to die. So door 3 starts to look like the statistical winner.
There's a computer scientist, Rizwan Virk, who wrote a book called The Simulation Hypothesis, and he adds a layer to this that I find really compelling. He talks about the simulation point.
Right, and this is what connects Bostrom's abstract philosophy to our actual real-world technological timeline. Virk is a video game designer. He's in the trenches.
Think about it. In the 1970s, the height of simulation technology was Pong. 2 white rectangles and a square dot bouncing back and forth. That was our simulation of table tennis. It was crude, It was barely recognizable.
And today, what, 50 years later, which is a blink of an eye in cosmic time, we have photorealistic VR, we have Unreal Engine 5 rendering cityscapes you can't distinguish from photos, we have massive multiplayer online worlds where millions of people are interacting in real time, we have haptic suits that let you feel impact.
Verk's point is that this progress isn't linear. It's exponential. We are getting very, very close to a point where we will be able to render a reality that is completely indistinguishable from this one.
And that moment is what he calls the simulation point. The moment the simulation becomes perfect, undetectable from within.
And his argument is, if we can see that point on our horizon, if we can imagine crossing that simulation point in the next, say, 100, maybe 200 years, then logic dictates that any civilization just 1,000 years older than us crossed it a long, long time ago.
It's the ultimate arrogance of the present moment. We look at our tech and we think, wow, we're almost there. We're about to become gods. But on a cosmic scale, if it's possible at all, it's already happened. We aren't the developers.
We're the content.
We are the content. We are the result of some teenager in the year 4000 booting up their history project for school.
Okay, so that's the logical trap. That's the big brain part of the argument. But I can hear the listener right now screaming, okay, cool, Matt, thanks for the anxiety attack. But I can feel this chair. I can taste my coffee. This feels real. Logic doesn't override the fact that if I kick a rock, my foot hurts.
Ah, the Dr. Johnson argument. I kicked the rock, therefore it is real.
Exactly. It's visceral. My senses are telling me this is real, and that feels more powerful than any philosophical equation.
And that is where we have to pivot. We have to pivot from logic to biology. Because that very objection, it feels real, is actually the weakest argument you can make. And to understand why, we have to look at the work of Donald Hoffman.
Hoffman, the cognitive psychologist. And he has this theorem that sounds completely backwards at first. Fitness beats truth.
This is a direct assault on our most basic intuition. We all assume that evolution shaped our senses to show us the truth of the world. We think, well, if I didn't see the tiger correctly, I would get eaten. Therefore, my eyes must be showing me the reality of the tiger.
It just sounds sensible. Accurate perception leads to survival. If I'm hallucinating all the time, I walk off a cliff. I die.
But Hoffman actually ran the simulations. He used evolutionary game theory, these are complex mathematical models of natural selection, to test this very assumption. He created digital organisms that saw reality as it actually is in all its complexity. And he made them compete against organisms that saw none of reality but were tuned entirely to what he calls fitness payoffs.
And fitness payoffs means what? Seeing whatever helps you survive and reproduce, regardless of whether it's actually there.
Exactly. It's the difference between seeing a candy bar as a complex molecular structure of processed sugars and cocoa butter versus seeing it as a big, shiny icon that says, delicious calories, eat me. One is truth, the other is a fitness hack.
And what was the result of his simulation?
It was a shutout every single time. The organisms that were tuned to see reality went extinct every single time.
Yeah.
He concludes that the probability that evolution shaped us to see reality as it is precisely 0%.
Whoa, hold on. I have to push back on that. You're telling me that seeing the truth is bad for survival. That just doesn't track for me. If a tiger is running at me and I don't see the tiger accurately, if I see a fluffy bunny instead, I get eaten. How can not seeing reality possibly help me survive?
That's the intuitive trap, and Hoffman loves that you ask that because it gets to the core of the misunderstanding. He argues that you don't see a bunny, you see a danger icon. If you actually saw the tiger as it truly is, a mind-bogglingly complex swarm of quarks and gluons, a massive shifting energy field, a quantum wave function, your brain would crash trying to process the data.
I'd blue screen.
You'd blue screen. You'd be eaten while you were still trying to render the physics of its left paw. You don't need the truth. You need a simplified version.
I need a shortcut.
You need a hack. Evolution hides the truth. It has to. Reality is just too complex to be useful for survival.
The best example of this, and I love this story because it's so tragic but also so funny, is the Australian jewel beetle.
The poor jewel beetle. This is the perfect, heartbreaking example of an evolutionary hack going horribly wrong.
So, set the scene for us.
Okay, so you're in the Australian outback. The male jewel beetles are flying around, and they're looking for a female to mate with. And to their brains, a female isn't the complex biological entity with a history and feelings. Their brain has a very, very simple heuristic, a rule of thumb. If it's big, if it's dimpled, if it's glossy, and if it's brown, it's a mate. That's their entire interface for procreation.
Enter the stubby. the Australian beer bottle.
Exactly. Humans started throwing these discarded beer bottles into the outback, and these bottles just happened to be big, dimpled, glossy, and the perfect shade of brown. In fact, they were often bigger and glossier than the real females. They were what biologists call a supernormal stimulus.
So the male beetles, they swarmed the beer bottles.
They completely ignored the real females. The real females were right there trying to get their attention, but the males didn't see them anymore. Their hack was hijacked. They tried to mate with the glass bottles until they died of exhaustion or got eaten by ants. The species nearly went extinct.
Because they were hacked. Their reality was just a simple rule for survival. And when a false signal appeared that fit the rule even better than the real thing, they couldn't tell the difference.
And Hoffman's point is devastating. We are the Beatles. We think we see the world, tables, chairs, the moon, other people. But we are just seeing our own species-specific user interface. We are chasing fitness payoffs that we label as beauty or food or safety. But none of those things necessarily exist in objective reality. We are all mating with the beer bottle and calling it reality.
He uses the desktop interface metaphor, which I think is what really makes this click for people.
It's the perfect analogy for our time. Think about your computer screen. You have a blue rectangular icon for an important document. Now ask yourself, is the actual document inside the computer blue? Is it rectangular? Is it physically located in the lower right corner of the hard drive?
Of course not. The file is a complex string of magnetic voltages in software code that's probably scattered all over the drive in bits and pieces.
Exactly. But if you had to get a microscope and manually toggle all those magnetic voltages just to write an email, you'd never survive in the modern world. You'd never send a single message. The icon is a lie. It's useful fiction designed to hide the insane complexity of the hardware so you can perform a task.
So Hoffman is saying that a table, a chair, a rock, these are just our 3D icons.
They are data structures rendered for you on the fly. When you look at a table, your consciousness renders the table icon. When you look away, the icon is, in effect, sent to the trash. The underlying data might still be there in some probabilistic form, but the table, as a solid physical object, does not exist when unobserved. Space-time itself is just the desktop. It's the user interface we evolved to navigate the code of reality.
Okay, this brings up the famous train objection. I always hear this one. All right, Hoffman, if the train speeding towards me is just an icon, why shouldn't I step in front of it? If it's not real, it can't hurt me.
And Hoffman has the perfect, elegant comeback. He says, I don't step in front of the train for the exact same reason. I don't carelessly drag my important document icon to the trash bin.
Not because the icon is literally the document.
But because the consequences are real. The interface is there to guide your behavior successfully. If you delete the icon, you lose the work. If you step in front of the train icon, your biological avatar gets deleted from the game. Taking the interface seriously is absolutely required for survival. But taking it literally, believing the icon is the reality, that's a profound logical error.
Okay, let's recap where we are. We have the logical argument from Bostrom saying we're likely Sims just because of the pure math. We have the biological argument from Hoffman saying our senses are lying to us anyway, creating a user interface. Now I want to talk about the engine itself, because if this is a simulation, it has to run on something. And any simulation has constraints. It has limited RAM. It has limited processing power.
And this is where we get into the physics of rendering. This is where it stops being philosophy and starts looking like we are living inside a PlayStation 6.
Thomas Campbell, a physicist who wrote a book called My Big TOEI, which stands for Theory of Everything, not the body part. He talks a lot about this. He calls it entropy reduction.
Which is really just a fancy way of saying efficiency. Campbell argues that any information system, any computer, is fundamentally designed to minimize the work it has to do. It wants to save energy. It wants to be lazy.
If you look at how we design massive open-world video games today, like No Man's Sky or Grand Theft Auto, we use this technique called lazy loading, or, more technically, Frustum culling.
Right, Frustum culling. A frustum is just the cone of vision that the player can see. It means the computer only renders the part of the world that's inside that cone.
So if I'm playing a game and I'm facing north, looking at a giant mountain, the computer is using all its power to draw the mountain, the trees, the clouds. But what about the entire ocean that's supposed to be behind me?
It doesn't exist. It's just code on the hard drive. The computer isn't wasting a single cycle drawing the pixels of the ocean because no one's looking at them.
And the second I turn around,
the ocean renders into existence, and the mountain behind you vanishes. It de-renders.
Okay, that makes perfect sense for a game. It's efficient. But why would the universe be any different?
That's the billion-dollar question. If the universe is a computed reality, why on Earth would it waste resources rendering the atomic structure of the surface of Pluto when no one is observing it? Why would it render the inside of an apple until you take a bite? It would be a catastrophic waste of computational power to render the entire universe, down to the last atom, at all times.
So the theory is the universe only renders what is being observed. And this isn't just a stoner theory. This connects directly to one of the most famous and profoundly confusing experiments in all of physics, the double-slit experiment.
The moment quantum mechanics broke our collective understanding of reality.
Walk us through this, but keep it simple. Pretend I'm 5.
Okay. Imagine you have a tennis ball machine, and you're firing tennis balls at a wall with 2 giant vertical slits in it.
Got it.
Behind that first wall is a backstop, like a screen. If you fire enough tennis balls, what pattern do you expect to see on the backstop? You see 2 piles of balls, right? 2 lines right behind the 2 slits.
Makes sense. The balls go straight through.
Now, let's shrink those tennis balls down to electrons. Tiny, fundamental particles of matter. You fire them one at a time at the 2 slits, you would expect to see 2 little piles of electrons on the screen.
But that's not what happens.
Not even close. You get what's called an interference pattern. You get a whole series of stripes, like when you drop 2 pebbles in a pond and the waves cross over each other. It means the single electron went through the left slit and the right slit and neither slit and both slits all at the same time. It interferes with itself.
It's behaving like a wave, like water.
Correct. It exists in a superposition of all possible states. In a way, it is a cloud of probability. It's potentially everywhere at once.
Okay, so matter is waves. That's weird, but all right.
But here is where it gets spooky. Scientists saw this and said, wait, that's bizarre. Let's put a little camera detector right next to the slits to see which one the electron actually goes through.
They decided to observe it, to look.
They turned on the camera, they fired the electron, and suddenly, the interference pattern completely disappeared. The electron went through just one slit, like a tennis ball. It behaved like a good little particle again.
Just because they looked at it.
Just because they looked at it.
This is the wave function collapse, the observer effect.
Exactly. And for 100 years, physicists have been tying themselves in knots trying to explain why. Does consciousness cause the collapse? Does the camera physically modify the electron's path?
But Campbell and Rizwan Virk say, it's not magic, it's not philosophy, it's optimization.
It's lazy loading. Think about that video game again. When the player isn't looking, the ocean exists as a wave of probability. It's just code. It could be rendered in a million different ways. That's the wave function.
Okay.
But the second the player turns around, the second an observer is introduced, the system has to make a decision. It has to render something. It collapses that wave of possibilities into one specific reality, one set of pixels at specific coordinates.
The universe only cleans up the probability and renders a definite state when someone looks.
Precisely. The particle exists as a probability wave, which is basically just data held in RAM, until it needs to be rendered for a player. Then, and only then, does the game engine collapse the probability into a specific pixel. It's an efficiency hack to save processing power. It's the universe not bothering to draw the back of the room until you turn your head.
That honestly explains the weirdness of quantum mechanics better than most standard physics explanations I've heard. It would explain why reality seems to be pixelated at the smallest scales, the Planck length. It's the resolution of the screen.
And why time seems to be relative. In a video game, if there's too much action happening on screen, what happens to the game?
The frame rate drops. It lags.
Time slows down for the computer because it has too much to process. In our universe, what happens when you get near a massive object like a black hole, or you move really, really fast? Time slows down for you. Einstein's relativity might just be the universe's lag management system.
Now, Rizwan Virk makes a distinction here that I think is important for the listener to consider. If we are in a sim, what kind of sim is it? Are we NPCs or are we playing an RPG?
This is a crucial distinction because it gets to the heart of who we are. In Bostrom's view, the ancestry simulation, we are most likely NPCs. We are non-player characters.
Like the background characters in Grand Theft Auto.
Exactly. We're sophisticated AI code that thinks it's conscious. Our memories, our personalities, our feelings of love and free will. It's all just part of the script being generated by the system.
That's the more terrifying option, honestly. It means I'm not really me. I'm just a very advanced chatbot having a conversation with another chatbot.
It is the height of existential horror. But Virk and Campbell lean toward the RPG model, the role-playing game model. This is more like The Matrix or the movie Avatar. In this view, we are conscious entities that exist outside of the simulation.
So we are the players, wearing a biological VR headset.
That's the idea. Campbell calls the place we come from, the LCS, the larger consciousness system. You are a subset of this greater consciousness. You log into this Earth game to learn, to grow, to reduce your own internal entropy, your own chaos. Your body is just the avatar you steer around. Your soul, if you want to use that word, is the player holding the controller.
So in the RPG view, we aren't fake, we're just visitors.
Exactly. We are visitors experiencing a constraint-based learning environment. And the constraints, gravity, pain, hunger, a limited lifespan, are the rules of the game, designed specifically to force us to make meaningful choices.
And that segues perfectly into the nature of reality itself. Because I think people get really hung up on the word fake. They hear simulation and think, if this is a simulation, then my love for my kids is fake. My struggle at work is fake. It's all a meaningless lie.
And this is where David Chalmers, the philosopher who wrote the book Reality Plus A, fights back really hard against that idea. His core thesis is incredibly simple, but also profound. Virtual reality is genuine reality.
Genuine is a strong word. You're going to tell me that if I'm plugged into a server farm somewhere, experiencing a fake sunset, that's genuine. That feels like a coping mechanism. It feels like something a tech billionaire tells you so you don't mind living in a pod.
Laughs. It does sound a bit dystopian when you put it that way, I get it. But Chalmers isn't trying to sell you a pod. He's trying to redefine what the word real actually means. Let me ask you this. What makes this table in front of you real right now?
Well, I can feel it. It's hard. It holds my coffee cup up. If I bang my knee on it, it's going to bruise.
Resistance. Consequences, cause and effect. Okay, so if a virtual table in a simulation holds your virtual coffee cup and you can't walk through it, and if you bang your virtual knee on it and you feel virtual pain, functionally, what is the difference?
The substrate, right. One is made of wood, the other is made of code.
But what is wood? What is it really? We used to think it was made of stuff, atoms, hard little balls of matter. But then we smashed the atoms and we found protons and neutrons. We smashed those and found quarks. And when we looked at the quarks, we found nothing, just vibrations, just mathematical relationships and energy fields.
It from bit.
That's the famous phrase coined by the physicist John Archibald Wheeler, it from bit. Every particle, every field of force, every law of physics derives its function, its meaning, its very existence entirely from binary choices, from bits, yes or no, 0 or 1, on or off.
So if the real physical universe is ultimately made of information and a perfect simulation is also made of information.
There is no fundamental difference in their reality status. If you live in a simulation, your pain is still pain, your love is still love. The substrate doesn't matter. Whether your consciousness is running on silicon chips or biological neurons or some cosmic quantum computer, the experience is the reality.
Chalmers has this great image of what God would be in this context.
Yeah, he reframes all of theology through this technological lens. We have this image of God as a, bearded old man on a cloud. But in the simulation hypothesis, God is just the programmer in the next universe up.
God as a teenage hacker.
Right. And the act of creation wasn't a booming voice saying, let there be light. It was a programmer typing, let there be bits. It was initializing the code. It was setting the fundamental constants of physics, the speed of light, the force of gravity, just like a game developer sets the gravity parameters in a game engine. Ooh, gravity's too low, the dinosaurs are floating away, let me just tweak this variable.
But there's a darker side to this virtual is real idea, isn't there?
Yeah.
We have to at least mention Jean Baudrillard. He wrote Simulacra and Simulation, which was the book that explicitly inspired The Matrix.
Right. Baudrillard was less concerned with the literal technology and more with the sociology. He was talking about hyperreality. He argued that even without a literal computer simulation, we have as a society already left reality behind. He argues that we have built a society of symbols and maps and signs that has completely replaced the actual territory it was meant to represent.
The map has become the territory.
It's worse than that. The territory is gone. We live in a world of copies with no original. I mean, think about money. It used to represent a physical thing, gold. Now it represents a digital number on a screen, which represents credit, which represents faith in an institution. It's just layers and layers of abstraction.
Or social media.
The perfect example, when you interact with a friend's profile on Instagram, are you interacting with them? Or are you interacting with a highly curated, edited, filtered simulation of them? Baudrillard uses this hologram metaphor. He says, when you pass your hand through a hologram, there's no resistance. But by passing through the hologram, your hand becomes unreal too.
We become part of the simulation just by interacting with it.
We are so deep in the symbols, in brand identities and digital personas and political narratives that the real underlying biological reality has just receded from view. We prefer the simulation. It's cleaner. It's optimized.
It's like the Beatles and the beer bottles all over again.
Exactly. The hyper-real beer bottle is more attractive than the real female. The hyper-real Instagram life is more attractive than the messy, complicated biological life. We are voluntarily uploading ourselves into a simulation structure long before anyone needs to build us a matrix. We are building the cage from the inside out.
Okay, we've done the logic, the biology, the philosophy. Now I want to get to the part that actually keeps me up at night. The hard evidence, the glitches. Because if this is code, there should be artifacts. There should be signs of the compression algorithm, right? Where are the pixels?
And this brings us right to the cutting edge of physics. A man named Dr. Melvin Vopson, he's a physicist at the University of Portsmouth, and he's studying what's called information physics. And he is proposing something absolutely radical, the mass-energy information equivalence.
Okay, we all know Einstein's EMC 232. Energy equals mass times the speed of light squared.
Vopson wants to add a third term to that famous equation. He's saying that mass, energy, and information are all convertible states of the same fundamental thing. He argues that information isn't just an abstract concept, it has physical mass. A hard drive full of data should, in theory, weigh infinitesimally more than an identical empty one.
And he has a law for this, the second law of infodynamics.
This is the potential smoking gun. In classical thermodynamics, the second law says that entropy, which is basically just disorder or chaos, always increases over time. Things break down, your hot coffee gets cold, your neat room gets messy, the universe trends towards chaos.
Right.
But Vopson looked at information systems like the genetic code in DNA or the arrangement of electrons in an atom, and he found that their information entropy actually tends to decrease or stay constant over time.
The system gets simpler, it gets more ordered.
It gets optimized. It behaves exactly like a data compression algorithm, like a zip file.
Give me an example of that. How does that work?
Let's look at this through the eyes of a developer. If you were building a whole universe from scratch and you had a limited amount of memory, because every computer has a limit, how would you save space?
I'd compress things. I wouldn't draw every single leaf on a tree individually if I could help it.
Exactly. You'd use something called procedural generation. You'd write a simple rule. A branch splits into two smaller branches. You just repeat that simple rule over and over, and you get a complex, realistic-looking tree. You don't store the massive data for the final tree. You just store the compact rule. Now look at a snowflake, or a starfish, or a human face.
Symmetry.
It's the ultimate compression hack. Why would you waste processing power rendering the left side of a face if it's just a mirror image of the right side? Vopson argues that the overwhelming prevalence of symmetry in nature isn't just an aesthetic choice by Mother Nature, it's a data compression algorithm at work. It's the system-saving RAM. If nature were truly random and organic, we should see way, way more asymmetry. But instead, we see these perfect, mathematical, mirrored patterns everywhere.
That is deeply unsettling. You're telling me my face is symmetrical because the universe didn't want to waste the hard drive space to make me unique on both sides?
Laughs. Roughly speaking, yes. Sorry. You're a low poly asset.
Wow. Okay. And then there's the ultimate speed limit.
The speed of light. Little letter Cecil, why is there a speed limit? Why can't we go faster? In a truly continuous, infinite physical universe, there shouldn't necessarily be a hard cap. Why 300,000 kilometers per second? Why that specific number? Why not infinite?
But inside a computer.
Inside a computer, there is always a maximum processing speed. There's a latency limit. Information cannot travel across the grid faster than the central processor can refresh the pixels. Vopson and others argue that the speed of light isn't a physical imperative of space-time. It's the clock speed of the simulation's processor. It's the refresh rate of the universal monitor.
Yeah, that gives me chills. It reframes the speed of light from a majestic law of nature to a technical constraint of the hardware.
And it explains why things get so weird when you approach it. Why does time slow down? Because the system is lagging. If you move your character too fast across the map, the rendering engine has to slow down the local time for your character just to keep up with the data stream. Relativity isn't a mystery, it's just lag management.
Okay. We are deep, deep in the rabbit hole now. I feel like we've hit the bottom. Let's try to synthesize all of this. Because when you start stacking these different arguments on top of each other, it stops feeling like a fun dinner party topic, and it starts feeling like a genuine existential crisis.
Let's stack them then.
The math says that if any civilization ever runs simulations, we're almost certainly in one. The odds are billions to one. That's Bostrom.
2. Biology says our senses are not a window to reality. They're a user interface designed to hide reality for survival. That's Hoffman.
3. Physics says the universe only renders what is being actively observed, which looks just like a computational shortcut from a video game. That's quantum mechanics through Campbell's lens.
And 4. Cosmology suggests the universe is governed by laws that look exactly like data compression and has a fixed processing speed. That's Vopson.
When you look at it that way, if it looks like a duck, swims like a duck, and quacks like a duck,
It's probably a simulated duck.
probably a simulated duck.
So what does that mean for us, for the person listening? Let's talk about the implications. If this is a sim, what happens to free will?
That's the big one. And it depends which model you subscribe to. If we are NPCs, the Bostrom view, then there is no free will, not a shred. We are just executing a script. The feeling of choice you have is just part of the code. We are the beetle humping the beer bottle because the code says, glossy brown object detected, initiate mating sequence.
That's profoundly depressing, but what if we're in the RPG model, the Campbell and Verk model?
Then free will is the entire point of the game. The larger consciousness system doesn't know what you're going to do. That's why it runs the simulation. It's an engine for exploring the decision space. You have free will, but it's within the constraints of your avatar and the physics engine. You can't choose to fly by flapping your arms. The physics won't allow it. But you absolutely can choose whether to be kind or cruel in a given situation. You can choose how you play the level.
And what about death?
This is where the simulation theory offers a really strange kind of comfort, but also what brand new kind of terror. If Campbell is right, death is just logging off. The avatar dies. The biological data structure that is your body dissolves. But the player, the core consciousness persists. It takes off the headset.
It completely removes the sting of mortality, the finality.
It does. But it replaces it with an even more terrifying question. Who am I really? If my memories, my body, my name, my relationships are all just the avatar's backstory for this particular game, what is left when I take the headset off? Is the player anything like me, or am I just a character mask that gets put back in the box?
And then there's the final mind bender, the last twist of the knife, the nested simulation.
We are getting close to building our own fully immersive simulations. We are building the metaverse. We are building powerful AGI. If we succeed in creating a simulated world with conscious beings inside it, and it seems likely we will eventually, then we become the gods of that world.
But if we are already in a sim,
Then our gods are also in a sim, and their gods are in a sim. It's just simulations all the way down, an infinite regress of realities nested inside each other like Russian dolls. And we have absolutely no way of knowing if we are at the top, at the very bottom, or just one of a trillion layers in the middle.
it makes you look at the sky differently, makes you look at, well, at everything differently.
It should. It's meant to. It turns reality from a solid, dependable fact into a giant question mark.
I want to end with a final provocation for you, the listener. I want you to look at your hand again right now. Really look at it. Wiggle your fingers.
It looks like skin and bone. It feels solid. But we know now, from physics and from biology, that it is mostly empty space. It is a vibrating cloud of probability. It is a data structure, an icon, rendered for your benefit.
You are looking at your own avatar.
And so the question isn't really, are we in a simulation anymore? The evidence stacks up so high that it seems probable. The real question is, what happens when we figure out the cheat codes?
What happens when we realize we can actually hack the interface?
Or even more provocatively, just think about tonight. Tonight, when you go to sleep, you will dream. Your brain will create an entire world from scratch. You will populate it with people. You will create a physics engine where you can fly or where you can't run fast enough to escape something. You will feel terror. You will feel love. You will feel pure excitement. And for those few hours, you will believe it is absolutely 100% real. You will have no idea you're dreaming.
You are already a simulator.
You are already running a perfect, fully immersive simulation inside your own head every single night. Who's to say that this waking life isn't just another more persistent level you play when you think you're awake?
Question your reality. Thanks for diving deep with us.
See you in the next render.